Hello everyone, thank you very much for joining this live event. It's the second lesson on Spring Security and we discuss about implementing the user details service. Of course, we have already discussed in the first lesson about the general architecture and we have implemented actually our first example with HTTP basic, but we want much more than that. And with this second lesson, we will learn everything about implementing the user details service, which you will see that is one of the components almost always present in an architecture with Spring Security. So you will find it from the simplest examples up to the most complex examples. For example, implementing your authentication and authorization with OAuth 2. So that being said, thank you again for joining. If you are watching the event live, don't forget you have the live chat there, so you can ask me questions directly in the live chat. If you watch the event recorded afterwards, you can still ask questions. You can place them in the comment section below, or you can find me on Twitter or LinkedIn and you can ask me the questions there as well, and I will either reply you in a separate video or in the next lesson depending on your question. That being said, let's recap a little bit what we have discussed in the first lesson. So I have started here already a diagram, and it's the same diagram we have worked on together in the first lesson. If you remember, so the request is intercepted by the authentication filter. You have here the authentication filter component, and then it delegates to an authentication manager which chooses from one of its authentication providers. You know, the authentication filter intercepts directly the request, and as you will see in the next lessons where we will go deeper into details, the authentication filter is actually part of an entire filter chain, and the filter chain is a chain of responsibilities, and each of the filters which represent the responsibility in the chain, they delegate further to usually a manager object, and that manager takes care of the responsibility represented by the filter in the filter chain. But I will go into these details a little bit later. For the moment, you can just take into consideration the authentication filter about which we discuss, and this authentication filter, as the name suggests, of course, represent the authentication responsibility, which again, authentication means to identify the caller, to identify the one whom is creating the request. So we want to identify the caller so that afterwards we know what is their privileges, we know what we can allow them to do. So the authentication filter intercepts the request. The request is delegated, actually the responsibility, the authentication responsibility is delegated to the authentication manager. The authentication manager has one or more authentication providers. In my simplest diagram here, you only see one. We will learn later that you can have more authentication providers. The authentication provider is the one to implement the authentication logic, is the place where you will see that if and else. If the username is the correct one and the password matches as well, then you are considered to be authenticated, otherwise you are not authenticated. So the place where you see the logic, the authentication logic, whatever that means, that's the authentication provider. And because in an application you might have different ways to implement the logic, for example in the HTTP basic we have a username and a password, but there are situations in which you do the authentication based on something else. Here in the authentication provider is the place where you write the authentication logic. And because we don't want to have multiple responsibilities in the same object, because that's not okay from an architectural point of view for the maintainability of the code, we delegate further, we split the responsibilities that are part of the authentication logic and we take them out into separate objects, and you can identify two separate objects that we use, which are the UserDetailsService. You actually here it's written JDBC UserDetailsManager for a reason, but for the moment I will call it the UserDetailsService. Is the component we have discussed about in the previous lesson. So this is a UserDetailsService for one reason I will explain later. I have called it JDBC UserDetailsManager and not service, but for the moment just take it as the UserDetailsService. For Spring Security, the UserDetailsService is the component that retrieves the user details somehow. So it somehow brings the user and the password for being authenticated by the authentication provider. And the password encoder is that component that validates if the password is correct, because in most of the cases you will be encrypting the password somehow. In the past lesson, in lesson 1, we have used the no-op password encoder. That is only for examples and that doesn't encrypt anyhow the password, but we will discuss probably starting with this lesson also about encrypting, hashing the password somehow, because you won't you don't want to store your passwords in plain text, otherwise they can be stolen, and if stolen then they can be used. If you hash them, they won't be one that's stealing them won't be able to use them anymore. So this is the architecture. Again, authentication filter intercepts the request needs to be authenticated, delegates the responsibility to the authentication manager. The authentication manager finds a proper authentication provider, and then the authentication provider finds the user somehow. In my example it's database, and I will implement actually today an example with a database, and then it validates its password by making use of the password encoder. Then it gets back, and if authenticated, then the details about the authenticated user will be stored in the security context, and then it can access the endpoint exposed by a controller, for example. If not correctly authenticated, an exception will be thrown, and then the requester will get back a 401 unauthorized. So this is the flow we discussed. Again, this is only a recap from the previous lesson. If you didn't see the previous lesson yet and you don't know these details, or you are not sure about them, you don't feel secure about them, go back to the first lesson. It's recorded and you find it here on the same channel, where everything is free and all the knowledge can be accessed by anyone wanting to learn Java and related stuff. So this is actually what we will also implement today. Just that what is different from the previous lesson is that we won't use anymore a direct implementation for the UserDetailsService. We will create our own UserDetailsService, and I will create a UserDetailsService which will use a database, and I will define myself the implementation, because in the next lesson most probably we will see that Spring Security provides also itself an implementation that allows you to connect to a database. I will also tell you in which situation you could use that one, and in which situation it's easier to just create your own. So you will find all these aspects, and we will discuss also the best practices and the differences between them. So this is what we want to implement today. We want to implement this component, the UserDetailsService, in a fashion in which the users are retrieved from a database. And then we'll discuss a little bit also about the password encoder, and we will see another contract that is called the UserDetailsManager. So a lot of things to do today. We'll see if we have time for all of them. If not, we will postpone them for lesson 3, but let's see how much can we do out of them today. So I hope with this recap of the architecture you have remembered the flow and how an authentication works, and which are the actors involved in the authentication in Spring Security. That means we should be able to go back to our IntelliJ and write some code in implementing an application where we do the authentication using Spring Security, but we store our user details in a database. So that's what I want to do. I will create the project itself now a Spring Boot project using Spring initializers in my IntelliJ here, and next I will have to select my dependencies, of course, after giving a proper naming for my project here. So actually I don't remember very well what was the name of the project. I might change it later. And I will maybe name it C2, or yeah, C2 is okay. So this is Spring Security C2, and I can choose version 11 or 13, doesn't really matter for us now. And then I have to select my dependencies here, and I need the web dependency, of course, because I will have at least one endpoint I want to secure. And then I have, of course, the Spring Security, because that's what we are discussing about. And because we connect to a database, we have to choose upon how do we want to connect to the database. And in this case, I will choose to connect to the database using JPA. Actually, as an implementation of JPA, I will use Hibernate. And because I will connect to a MySQL database, I will I will need also the MySQL dependencies. So that means Spring Data JPA has to be added as well to my dependency list, and then MySQL needs to be added as well to my dependency list. And that's it for my example. At least I think these 4 dependencies for the moment should be enough for me. So I go next, and then I go on finishing creating my project, and I can check if the dependencies have been correctly added by opening my POM.xml file, and you see they are indeed. I have the JPA here, I have the Spring Startup Security, I have the web dependency, and I have the MySQL connector, which is only needed for runtime, of course. So that means we can implement our first endpoint, and you know that by default, because I have the Spring Security dependency in my POM.xml, we discussed this in lesson 1, Spring Boot will create some auto configuration for me, and that is that user in memory with the auto generated password in the console. You'll see that immediately again. I won't use it anymore. Does Spring Data JPA use Hibernate internally? Very good question. Thank you very much for the question. So yes, Spring Data JPA has as the default implementation Hibernate, and you will see this in the console immediately when I will start the application. Hibernate is probably the most used, and from my point of view, the recommended implementation, the recommended JPA implementation you should use today. Okay, let's create the endpoint, start the application, and you will see Hibernate appearing immediately in the console as well, which will even better answer your question than me, because you will see it directly there in the log, in the console log. So I need a controller, and I will create just a simple endpoint because it's not doesn't really matter what we do here. So we have a hello controller, and the only thing we need is a hello endpoint. So because it's a REST controller, I will have to add the proper dependency, and then because we want an endpoint, so it's public string hello, and I need a get mapping. And I want to recall what I have said in the first lesson. Don't forget, for the moment we use only get for a reason. If I would use post here, it won't work. I wouldn't be able to call directly the endpoint because we have a default CSRF protection implemented by Spring Security, but that's something that I want to discuss in the next lesson separately. So that's why for the moment it's only get endpoints, but I will get to the post, put, delete endpoints and the others in one of the next lessons where we discuss the CSRF first, and only afterwards you will understand properly how and why I have used only get for the moment. So in order not to mix them, that's why I will only have get endpoints for the moment. So yes, we have here the implementation of the endpoint, and I won't be able to start the application. Actually, if I try to start the application, I can try, but it will fail because being that I have added the JPA dependency and the MySQL driver, Spring Boot automatically knows that I want to connect to a database, and guess what? I didn't specify any data source, and because I didn't specify any data source, it will tell me I can't start the application. You have to give me a proper URL for your database to connect and some user and password for getting the right privileges. So I expect it to fail and ask me for the needed. So it tells exactly what I expected. It failed to determine the database because I didn't configure any data source. So of course it expects the data source to be there, but I think I should be already able to see some Hibernate here. If not now, it will be later, but in the logs here sometimes. Okay, this is what I wanted to see to actually properly answer your question. So yes, to complete to finish the answer for your question, thank you very much again for your question. You see here the default implementation for JPA with Spring Boot is the Hibernate implementation, so that's why I mentioned Hibernate. So that's what we are using here, and it comes out of the box. You don't have to do anything for it. Just add the JPA dependency, and Spring Data JPA automatically adds your Hibernate implementation. Okay, cool. We know what the problem is. Let's finish the problem. So let's finish the problem. Let's solve the problem. Sorry for that. And I need a database, so that's why I have actually opened MySQL here. I prefer to use MySQL and not an H2 in-memory database to be more explicit on the fact that we actually connect to a different system and we don't. It's not all inside our application. I use usually MySQL because it is the lightest probably that I can use, and I have already a database here which is empty, is called Spring, and I will add a table where my intention is to store the users. So here tables and users. Actually I will use JPA, which means that my class name should match the table, otherwise I have to add one more annotation, the @table annotation, and because I want to avoid that and to keep the name of the class at singular, then I will name the class user and not users. And then I have an ID to make it easy. Actually, I won't create anywhere users, but yeah, let's make it auto increment. And then I have the username, which can be a varchar, and then I have the password, which for the moment can only be a varchar as well, because I will store it in plain text. Yes, I know. Don't throw your tomatoes yet. I will show you how to hash the password. I've told you from the beginning. I will show you how to use a proper password encoder, but for the moment let's focus on the UserDetailsService, and I will for that use that same no-op password encoder, and that's why I will have for the moment to store the password in plain text. But that's something you shouldn't do, and I will show you how to avoid that for a real world scenario. So once we get to explaining the password encoder, I will also tell you what password encoders can you use and why should you use them to hash your passwords when storing them in the database or anywhere, doesn't really matter where. So now I have my table here, and I will select I have no user, so let's add one user, which will be Bill, and the password 12345. Again, never define passwords as 12345 in a real case scenario. This is only for our application to make it easy. So I have one user now. I think everybody agrees that I have a user and I have a table and I can connect to the database, and my intention is to use this to connect. So I go back to my IntelliJ finally, and that means that I can go to the resources application properties file, and I define my data source. I at least need the URL, which in my case is a MySQL, so it will be JDBC MySQL, and then it's on the local host. The port is the default one, 3306, so I can avoid writing it. And then the name of the database is Spring, and then my installation is a default one, so I have the username root, but the password is not set, so it will be empty, which is of course not desirable for a real case scenario, but for my local host example, server is more than enough. Okay, one more question. What is good practice in today's cloud environment? We have the authentication authorization on the edge, API gateway, or have it in the app? This is a really difficult question, you know. It's not a question that I can answer in 5 minutes, but I will actually try to give you now a short answer, and I promise to cover a lot of this of the part of the answers in the next lessons, because I would have to discuss. I can discuss actually more than a day on this subject. So I will shortly try to answer your question now. There are two ways to set the authentication. You can set it in the gateway, which I have seen a lot of times happening, and fits for it's a great fit for a lot of architectures, and it's a correct fit. And that depends on exactly what do you expect, how do you expect the messages to go behind your gateway. Do you expect them to be in the same data center or to be somewhere in multiple data centers? Because when the traffic starts to go through the public network, then it's not okay anymore to have unauthenticated traffic. So in this case, if we assume that you have a gateway and then you have a microservices systems behind, and everything is in the same data center, then if it doesn't get out of the data center, and we assume it's secure enough to have the authentication only at the gateway level, then probably is the best solution to keep it only there for maintainability. But if you are into a situation in which your microservices communicate from multiple availability zones, then it's probably better to have a way in which you do the authentication between them as well. And by this I mean at least sign the requests, so that a service can make sure that the request is coming from a real source of your system, and not from somebody else that has done a man in the middle. So again, a very complex question, so I will promise to answer it piece by piece in the next lessons, and give you more insight into this, but the idea is that it depends. If it depends on how you deploy your architecture, it depends on if you want to assume and it's okay, it's fine for you to have unauthenticated traffic after the gateway. I have seen that implemented. I think it's correct in some situations. I think it might be risky in others. So it depends. You have to choose it based on the deployment and your architecture and your application, to make sure if it is or not the correct choice for your example. But if possible, I would go to the simplest solution. So if I don't assume that the traffic is communicating between on the public network, then I would go to the authentication only on the gateway, and then you can leave your traffic unauthenticated, at least up to the microservices behind. But again, it depends. So I hope at least I have shortly answered your question, and with working on this stream, as well as when we get to the part that refers to OAuth 2, then we can discuss even more about this subject. And don't forget that besides the Spring Security, you also have the possibility to use a service mesh like Istio to secure the microservices behind. Yes, exactly that's what I wanted to say as well. If the API gateway gets hacked, then it means that one would have access to the microservices behind. But usually that's much more difficult to happen if you don't have traffic from the gateway to the microservices behind. So that's why Okay, yes, I will make sure to also give you more insights on that, but let's now focus on the today's subject. It's a really difficult question. It's not an easy one. It's not one for which you can spare 5 minutes and answer the question. That's it. And a lot of solutions for it. Again, a service mesh is very useful today, like Istio, to implement something like this, and you can benefit of the fact that you can take out this part from your application. Like, you won't implement it with Spring Security anymore. You take it out at a higher level, and that's very comfortable, because especially in a microservice environment where you don't necessarily have all the microservices implemented with the same technology. Maybe one of them is Python, maybe the other one is a C#, and maybe you have one that it's Java as well. It's much more difficult to implement security as a layer on the application for each of the microservices. But if you put it on the service mesh level, so a little bit upper, then you do it once for all the services, and you don't care about the technologies, the platforms in which you have implemented. So it's a lot to discuss on it, but I hope that at least I have given you something, and at least my opinion for the moment. Both of them are okay. It depends on the risk you want to assume. So if you can assume the risk that you don't have public communication between the gateway and the services behind, and you assume that, as somebody also says here in the chat, you assume that you don't have a big risk of somebody hacking your gateway, then you might want for simplicity to leave them unauthenticated. My opinion is that you usually have to have something anyway also for authentication, but you go to the simplest solution that relies to your application. And let's discuss more also later on this, and focus also on focus more now on what we have started to implement here on Spring Security, because your question is more architectural than security than related to Spring Security at the moment anyway. But I'm really glad to discuss a lot about it. You see, I have already spent more than 5 minutes to do this, and if you start me, then you won't be able to stop me, and we have to stop after 1 hour anyway. Okay, so I have configured here. You see the URL and the username and the password. So I should be able now to start my application, and I think it should now start actually. That's because I have given a proper data source to connect to, and we also have a table now, and we also have a user. But because we didn't configure anything about the user yet, guess what? You see what happens here? Again, we have that default implementation of the UserDetailsService. So that's not actually what we want with this lesson. We want to have our own implementation, and not the one that's generating that default security password, about which we have plenty discussed in lesson number 1. So how do we manage to implement our own UserDetailsService? We do create a configuration class, of course. So I prefer to create a config package, and I have this configuration class, and I name it project config. And to be a configuration class, then I annotate it, configuration should be okay. And then I declare my beans. One of them is the UserDetailsService bean. The second one is the password encoder bean. So I can start with the password encoder, because the password encoder, we have already discussed that we will still use that no-op password encoder, which you shouldn't use in a real case scenario. We go later, and we will discuss later more about password encoders, but for the moment we use this implementation that you see it has also been marked as deprecated, so that you can easily see that it's not something you should use in a real case scenario. And the second one, which is of course what we want to implement, is the UserDetailsService. And the UserDetailsService, for the moment we don't have this implementation yet. This is the contract in which you have the behavior loading your user details by a provided username. So this string here as a parameter is the username, it returns the user details. You already know from the first lesson that this user details service is the contract that Spring Security needs to find the user. Here it finds the user by calling this behavior here. This behavior should return the user details. The user details is the contract, the interface in Spring Security representing the user. If the user is not found, then it should throw the username not found exception. I remember somebody asking me in one of the Java fundamentals stream, I think, when should we throw exceptions in an interface? For example, this is a very good example. This is a runtime exception. Actually, it's not even a checked exception. You throw it here for documentation purpose. So it doesn't change anything by throwing here a runtime exception. The only thing that it makes is that it reminds me always how this method works. It reminds me that this method should throw this exception if the user doesn't exist. So let's implement now our own user details service. I will create a separate package here, services, and then I will create let's call it JPA user details service. What do you think? Is this a good name because we are using JPA? Maybe not, but I'm not much inspired now, so I will use this name. And user details service is of course the contract I would like to implement, and that's where I need to override my load user by username method. You see here I don't have to throw it anymore here because it's anyway only a runtime exception, but you keep in mind that this exception has to be thrown when we don't find the user. To make it actually I have declared the method here and I will use bean, so in this case I don't have to put the component annotation anymore because I will either use bean to create the bean in the context or use the add component, whatever you want, but one of them it doesn't make sense to be both at the same time, so both of them do the same. They will create an instance in the context. So in my case, to keep it coherent with the previous implementation, I will create this only as a simple class. I won't add the the component annotation here, but I will return an instance of type JPA user details service here. And this is how I created as a bean in the context. So again, either you create a bean method, a bean annotated method in the configuration class, either you put that component, one of these will do basically the same in the end, will have the same effect, will add this instance in the Spring context, and that's where we want it to be. And now I go here and I have to implement. So I have to implement this logic where I take the user by username. This is the username, actually. We name it like this to be more clear, and return it as a user details. That means we need a way to take the user from the database. So we use Spring Data JPA. That means I will create my repository. So I will create a separate package. I will call repositories, and repositories will have my user repository, and to have the user repository, which in Spring Data is, by the way, an interface, I need first to have the JPA entity, and the JPA entity represents the table in the database. So by the way, if you don't know what all these are and you need more details about JPA, I have just finished a 16 lesson stream on this same channel. It's recorded, you find it there, about JPA and Hibernate, so you can follow that stream to learn all the basic details you need about JPA and Hibernate. I will assume you already know this because I can't teach you now also JPA and Hibernate, but I have 16 lessons there already on this channel. It's separate playlist, just open it and learn from it, and if you have questions, don't forget to ask me. I will create the entities package as well, entities, and inside my entities classes then I will have to create my user and an entity in JPA with annotated with @entity, and now it became actually an entity. And then I have to declare the fields. One of them is the ID. Okay, If I have made it auto increment, then I have to specify that the generation strategy is the one named identity, and I also have a string username and a string password. Then I will create getters and setters for all of this, and I can use my entity now. So what I have to do is to go back to my user repository and make it extend JPA repository, which in Spring Data is the contract we use for JPA repository. And then I have to specify the name of the entity, so I will have a user and the type of the primary key, so user and integer in my case. Okay, I do the correct imports. Yeah, so here it is the type and the ID. They are they are everything we need basically. And now we can find the user. Optional. Nah, I don't know what happens here, but probably I'm moving too fast. So optional of user is the return type, and I have it find user by username. Okay, so we need a method to find the user by its username. You know, in Spring Data you don't have to define the query because it will automatically convert the name of the method in the query itself. You can add the query, however, by adding the query annotation if you would like. You can even use native query, but that's not recommended. Again, more details on this you can find in the playlist regarding Spring Framework that I have also recorded, and you can find it available here on the same channel. So now I have the method which is returning my user by its username. I go back to the services, my JPA user details service. I inject the repository by using AutoWired. So private user repository, and usually I do recommend using AutoWired on the constructor. I never use in practice AutoWired on the field, but for examples and for POCs is very comfortable because it's much more easier and we don't focus on things that we don't want to see. So that's why I'm using it on the field, but my recommendation is on in a practical scenario, in a real life scenario, make this final and make the injection through the constructor. Okay, then I have the optional of user. Okay, yes, my ID used to be more intelligent, so IntelliJ used to be more intelligent, but I see now that it doesn't recommend me a lot. I write more and more than I think is needed, but that's doesn't matter. I can even do that in Notepad, so it's not a problem. And what I do here, I will say, okay, I want the user, and I will say find. So I would say or else throw. Actually, I think the best is to use the or else throw method and specify that we need to throw that exception. I have deleted here. So is the username not found exception. This is what happens if we don't find the user. So what do I have to write here? I say get me the user or else throw an exception of type username not found exception. So this is how it works. This method or else throw receive this parameter. This is a supplier. The supplier needs to have also an error message. Generally make it more decent than just error, so put a decent message there so somebody really understands what happens if they get this exception. But I make my examples shorter now. So this is a supplier, and this supplier will create a new exception and throw it when the user doesn't exist, so if this optional is empty. And now I have the user, but be very careful, I cannot return it here. And the reason why I can't return it is because my user doesn't respect the interface, the contract from Spring Security. So I have the possibility to either make this class implement the interface and make it also a Spring Security user, but that's not really my choice or my preferred choice. We can otherwise create a separate class representing this user. I will create a separate class. Let me tell you why. Because you always have to respect the single responsibility principle, and I won't mix my entity with the Spring Security user. I prefer to decouple them, make them two separate classes instead of putting them all together into the same class. By the way, this code will become a lot more difficult to understand if I would do mix these two responsibilities into the same class. So what I will do now to make it easier for me to read and understand, I create a separate user. I will name it the security user because this is the user as Spring Security needs it. I will implement here the user details interface. That's the contract representing the user in Spring Security. I will override all the needed methods here, and I will make this security user actually a wrapper over my entity. So what I do here, I declare a private final user. This is my user entity, user as a field, and then I will make sure that this is obtained through the constructor. So I always need it because it's constant, so I take it through the constructor. And then what I do, well, I didn't define any authorities in my case, and you know, we didn't discuss authorities yet. So what I will do here, I will simply create a list of, for the moment, only one hard-coded here authority. So I will do it like this. I will name it read, and don't mind it for the moment. Don't take this method into consideration. We will learn that this method represents the privileges of the user, but because now we don't discuss about it, I will hard code it. Generally, it will be a second table in the database. So generally, this will be a second table in the database. So I see now another question. Is it good idea to have passwords in different table? If yes, how we can manage it with Spring Security? Honestly, I didn't use passwords in a separate table until now. I don't see a benefit for it. Because anyway, if somebody hacks your database, it will probably have access to all the tables. But if you do that, like put them in a separate table, then it will be a little bit more complicated to manage them, but it's still possible. Like imagine here I only take the user, but when you will have them in a separate table, then we will most probably have a relationship, the user with that table, isn't it? So because you have the relationship like in JPA, you will have another field here where you can take the password from. So it's the same thing basically. It's the same thing, just that instead of just having the field here password, you will have an object to which you will have a relationship, and then that object will have the password. So technically it's not a problem, and it's not much more different than what we do here. I don't see any reason, however, for why I would complicate this. I won't do that because I don't see. Maybe you can give me an insight what you are thinking about, but from my point of view, I don't see a benefit out of it, and I didn't see somebody implementing it this way for any reason for the moment. I would say don't complicate if not necessarily. So now I have do I have a security user, and I have the authority, and then the password will be user get password. So here in your case, if you put it in a separate table, it will be probably users get something and then get password. It will be a relationship between the two objects, so it will only be one more differentiation to get the password. And then you have the username here as well. And because we have no logic on our account expiring or credentials or anything, we just put them true, and true for the moment. So our account never expires, and the credentials never expire, never gets locked, and is always enabled. Okay. Otherwise, of course, this maybe probably have been also some columns in our database, but it's not really important for the moment for us. So I have my user with only one privilege. About privileges we discuss later. The most important things for the moment, the username and the password, and that's what I can actually return now from my service. So I will do new security user, and I will deliver the entity I got as a parameter. So you see here it's pretty easy. On this line I take my result from the database based on the username, and then I can have either an optional that contains the user, either an empty optional, and then if the user is not found, so if the optional is empty, I will throw this username not found exception. Otherwise I get the user, I wrap it in an object which is understood by Spring Security, and I deliver this instance back to Spring Security, because that's Spring Security. Actually it's the authentication provider implementation from Spring Security that will call this method to get the user. And I think that's basically it, because now we should be able to use properly our implementation. So let's see, we have to restart it first, and I will try to call my endpoint from Postman. So let's create one more tab here. It's a get endpoint, so my URL is localhost 8080 because I have the default port and I have a hello. Of course I cannot call this directly, or I can try, but I will get probably a 401 unauthorized. The application is not started yet probably. Let's check it. So it's still starting. Okay, only now has completely start, and okay, it's 401 unauthorized. And now we can go to the authorization, and I will select basic authentication because that's what we are using. I don't remember precisely which word so it's username Bill and 12345. So here it should be Bill, and the password 12345. Remember what happens with these credentials: they will be concatenated with a colon, and then they will be base64 encoded, and they will become part of the authorization header. So here the authorization header, when I do press send, probably it will happen, it will add my authorization header, and this is what you see here. This is the encoding of the username and the password separated with a colon. It's just an encoding, it's a base64 encoded. They are not encrypted anyhow. This is not secure, it's just an encoding. You can turn it back anytime, the username and the password. That's why we always use HTTPS. And if you need a more secure way to encrypt this, then HTTP basic is not the authentication choice you need to take. And that's when we will discuss later about filters. We will discuss about the possibility to customize your authentication. For the moment we only use HTTP basic so that we can focus on the other components, because it's much more important for the moment for you to understand the other components, and then you will understand the complete big picture of authentication. So you see, by using the proper username and password, I was able to get back the hello in the response, and I have of course 200 OK response status, and that's cool. So we have just implemented our first application where our users are stored in a database. You see them. I have my bill here in my table, and I have even managed very easily to create my UserDetailsService implementation that uses a Spring Data JPA repository to find the user, and that user is the one we have stored. And now we can use users from our database and authenticate to get the request with them. So more about the password encoder now, because I have left you with using this password encoder, which is not basically the one that you will actually use in a real case scenario. You don't want to have passwords stored as a plain text. You need to hash them somehow. And that's why usually we will use a password encoder that hashes the password. And my recommendation is that you should use bcrypt password encoder. So that's probably the mostly used and the more efficient way to hash your passwords for the moment. Spring Security does offer you more implementations. So if you go here and see all the implementations, you will see that bcrypt is one of them. Or some of them I didn't hear. So this Argon 2, this is the first time I see it here. I will check it out. But bcrypt is one of the most used. And then of course we have some password encoders that used SHA or MD4 that are deprecated. You shouldn't use them anymore. We have the PBKDF2 password encoder, which uses a key to hash your password. We have the script password encoder. Standard password encoder was using SHA algorithm to hash the password. This is also deprecated now. You shouldn't use it. So we will stuck with the bcrypt password encoder. But now if we use the bcrypt password encoder, which is pretty easy, so instead of returning here the no-op password encoder instance, you would actually return bcrypt password encoder, and that's it. And I will restart now the application. Actually our implementation won't work anymore because this won't accept to find the password that is in plain text. It will expect me to load from the database a hash that is a bcrypt of the hash itself. So before doing something like this, before actually using the bcrypt password encoder, I will prefer to discuss with you about the UserDetailsManager. I will shortly introduce you now the UserDetailsManager, and then I will continue with the password encoder and authorization rules in the next lesson. So I will keep for the moment this no-op password encoder we have started with, and then I want to discuss about the UserDetailsService more, and not about the UserDetailsService actually, but about an interface that is inheriting the UserDetailsService, and that is called the UserDetailsManager. So have you seen, and maybe you have spotted in my first diagram, the diagram I have started with at the beginning, that this thing here was called JDBC UserDetailsManager, and maybe you wondered why is it called the manager and it is not called the service. Well, basically this is because I actually wanted to discuss about the UserDetailsManager today, and the UserDetailsManager is contract that extends the UserDetailsService. So you see here the UserDetailsManager is basically a more particular UserDetailsService as well. The UserDetailsService is the object used by Spring Security to retrieve your user. You have seen that, and today you have even implemented one of your own. You have implemented the UserDetailsService to allow Spring Security obtain the user from the database. But sometimes you need more than that. Sometimes this is the minimum Spring Security needs. Spring Security doesn't need more than just allowing it to find the user. You do allow it to find the user, the authentication works. But sometimes you want also to be able to create users. You want also to be able to change their passwords, and so on. The object that manages the users, so that doesn't only retrieve them for Spring Security, but also is able to add them, update them, and so on, delete them, and so on. This object is called the UserDetailsManager. So the UserDetailsManager extends the UserDetailsService, is a UserDetailsService being able to allow Spring Security find the user, but allows us also to implement more functionalities, out of which also the creation of the user, and that's what I need to do next. And the reason for why I need to do this is because to use a bcrypt password encoder, first I want to make sure that when I create the user, I do create it and hash the password before storing it in the database. So I won't be able to just write the password by hand in my database as I've done in this exercise. I will have to be able somehow to call an endpoint and add this user, and this is basically what we will do. We will implement in application in the next lesson, in lesson 3. Just an introduction of the UserDetailsManager so that you see what it contains, and I will also provide you with some implementations of UserDetailsManager as well that Spring Security provides. And then in the next lesson we will be able to create our own UserDetailsManager. With that we will be able to use a different password encoder, and then we will also learn about specifying authorization rules using matcher methods. So let's see, a user details manager, besides the fact that it extends the user details service and by that allows Spring Security to find your user, it's also able to create a user, to update a user, to delete a user, to change its passwords, and to return if the user exists or not. These five behaviors, they add to the one inherited from the user details service, which is load user by username. And basically what happens is that you have actually used in lesson 1 a user details manager, even though you didn't call it that way. Do you remember we have implemented an application in which you use the in-memory user details manager? So why is the in-memory user details manager called a user details manager and not a user details service? Of course, you guessed, because it is a user details manager. If you go and see its implementation, you will find out that the in-memory user details manager we have used in the first lesson, it's actually a user details manager. And because it's a user details manager, it's also user details service, and that's why we were able in the previous lesson to use it as a user details service. But you do remember that in the previous lesson I had to add my own user. So do you recall what method did I call at that time to add a new user? Of course, it was precisely the create user method. Maybe you wondered at that time, where did this method come from? How was I able to call a create user method if the user details service only describes the find user by username? Well, the reason for why I was able to create a user inside an in-memory user details service by calling the create user method is because this in-memory user details manager is more than just an user details service. It actually adds the behavior of the user details manager as well, and it's able to allow me creating the user as well, deleting it, and so on. So that's what we want to discuss in the next lesson, where we will focus into creating a user details manager, and then we will see also more about how to use proper, let's call it password encoder, and then the next subject is using the matcher methods and implementing authorization. That's it for today. Thank you very much for being present here with me. Thank you very much for all your questions. Sorry for not being able to now completely answer you to all your questions. Like in the case of that most architectural question, basically, as I've told you, it can take me more. I can talk about it more than 8 hours and still not touch all the things that I would like to discuss. But during the entire stream, I will refer back, and you will find these pieces of juicy information all over this stream, and hopefully when everything ends, you will have a lot of information, and you will know my entire opinion also from the architectural level. But being that now I'm only at the beginning with this stream, we have just started to discuss the basic authentication and authorization architecture, so it's not a lot now, I know, but this will make sense overall in the end when we have touched all the details, and you will see it's really important to understand these components, basic components first, before trying to understand the more complicated ones. Thank you very much again, and hope to see you also for next lessons. Have a great time for learning.